mention something in the chat?
Oh, it's just me asking if everyone had a push button on theirs. For life me, I don't know why I didn't have that or was able to share my work.
So if I've got the chat window in the middle of my screen, do you see a blank part of my screen?
I could save it and stuff, but I don't know how I'm able to actually share what I've done, and I don't know why it wasn't coming up on your screen. I'm baffled, but yes, it is what it is.
Christian, are you asking if we can see the Zoom chat right now?
Yeah.
No, we can't. We can just see the PowerPoint.
Okay, fine. So explain the connection between the circle, the sine, the cosine, and the tan function. So that's what we're going to try and do today, okay? So remember what we did last time? We looked at a sine signal, a cosine signal, and we added the tan signal there. Okay, so I'm not going to go through those construction. We've done that last week. Now, what we can do here, when we looked at drawing those graphs last time, we looked at drawing them around a circle, if you remember well. That circle meant we went from 0 to 360. And that's why on the x-axis here, we've got 0 to 360. And what we can do is we can split our circle into 4 portions or 4 quadrants. The first quadrant would be from 0 to 90 degree. The second quadrant from 90 to 180. Then the third from 180 to 270. And the fourth quadrant from 270 to 360. Hence those portions here. Part 1, part 2, those are just quadrants. So why do we do that? Because if you look at those signals there, tan, sine, and cos, this is 0. Anything above 0 in algebra, we call them positive numbers. So there's your integers. So positive numbers, so all my signals are positive in that first quadrant. In the second quadrant, only the sine is positive. Have you noticed that? In the third quadrant, only the tan signal is positive. And in the fourth quadrant, only the cosine signal is positive. So this is interesting to observe because I'm not sure if you've heard about people mentioning, oh, we use the cast diagram to solve a trig equation. So if you've heard before the cast diagram, you're going to see where it's coming from when you know what the signal looks like. So, like I just said, by going through those quadrants, all my signal are positive in that first quadrant, sine positive in that second quadrant, tan in that third quadrant, and then cos in that fourth quadrant. And if you think about going from 0 to 360 and you use the first letter of all those words here, you've got C, A, S, T. And that's what they mean by the cast diagram. Okay. So if I've got an angle here, let's call it X degree angle. In this portion here, where sine is positive, I've got 180 take away this angle. So if I was to draw 180 take away this angle would be here. In here, I've got 180 plus this X, and here I've got 360 take away my angle here. So why are we saying this? I'm going to show you that in a minute. So let's say I get a problem given to me where they ask me to solve for 0 to 360 sine x equal 1. Yeah. So I'm looking at my graph there, 0 to 360. My sine signal goes from 0 to 1, comes back down to -1, and at 360. So the only time where sine x is equal to 1 should be when x is equal to 90 degree. So what we're trying to solve here so as you can see here is x equal 90 degree for sine x equal 1. Now, like I said, this is 1. It's a bit like you drawing this with a pen. It's a bit like someone asked me to draw a line here, and where is my sine signal equal to 1 when x equal 90 degree. So that's how you would solve this using a graphical solution. Now, cos x is 0 between 0 and 360 at 90 degree, 270 degree. So this is my cos signal, and it cuts the x-axis here at 90 degree and at 270 degree. So you can call these, if you want, the x-intercept. Tan x, when is tan x equals 0? At this point here. And I've got another point where it's equal to 0, this point here, and another one here at 3 points. So if you're asked, solve tan x equals 0, you would say tan x equals 0 when x equals 0, 180, or 360. When is sine x equal -1? So you look at your sine signal. Oops, this is where it touches the -1 point. And what is x, the value of x this time? So what do you read for x at this coordinate? 270. Yeah, 270. And for the last one, when is cos x equal 1? Between 0 and 360. It's at this point here and this point here. So you could get asked by using your drawing skills to solve these. So we've solved all these just using the graph itself. So cos x equal 1 when x equals 0 or x equals 360. Okay. So now this was easy because it was just 1, 0, 0, -1, and 1. So you might be asked to solve sine x equal a half, for example. So you would need to draw the line here. So let's say someone asked me to do cos x equal a half, right? I'm going to change the color to black. So you could come here and say, I'm going to draw a line at half. Yeah. So there's my line where cos x equal a half. So can you tell me how many solutions do we have? How many times that line cuts this sine between 0 and 360?
Twice.
Twice. So you can see you've got one solution here. Yeah.
Mm-hmm.
And one solution there. It'd be hard to say what is that value, but do you know why you've got two solutions? Remember when we did cast? Yeah. So what did we say in the first quadrant? All the signals were
180 or A's positives.
Yeah, all the signals were positives.
Yeah.
So that's probably my first one there. And then we said cast, so we had C, A, S on this side, and T. So sine is positive in that second quadrant, which is why we've got it here. That's your second quadrant here. Remember the quadrant we said this was 1 and this was 2. And that's why you've got two answers when you've got sine x equal a half. That's where the two answers are coming from. What you need to do is just find the first answer, where it's all positive. So this is this one there. We're going to call it alpha. And once you've got alpha, the second one is just 180 take away alpha. That'd be your second answer. So if you've got your calculator and it's in degree mode, so shift mode to make sure you're in degree, and you do shift sign. So shift sign. So if you all type shift sign of a half, so you can write it as 0.5 or as a fraction. So what do you get? So shift sign, which is sine minus 1, yeah, of 0.5 should give us the answer, which is 30 degree, yeah?
Yeah.
Yeah, so you got here, the angle here is 30 degree. So you would say my first answer, x in degree is 30 degree. This is us solving sine x equal 0.5, right? That's my first answer. And my second answer that your calculator doesn't give you, but you know that second answer is here, is at 180 take away that angle. So what's 180 take away 30?
150.
150. So that's you. You've got all your marks. And we can pack up and go home. No, I'm just kidding. Okay, so that's how you would solve a trig equation. You would try and find out all the possible solution. The good thing is, after you've got an idea now what the graph looks like and where it should cut. So that should help you when you're going to solve, more complicated trig equations. Okay. But this is the basic of it. If you know the CAS diagram, you know where they're both positives. It's in these two quadrants. Once you find the angle where they're all positive, then you can find the second one. And that's what we're going to be looking at today. Solving trig equations of the form a sine x plus 1 equals 0, because we know how to solve an equation. You just treat as if that big sine x was a big X. That means you need to take away 1 on each side and then divide by a. Okay, so let's have a look. We've just done this one, sine x equals 0.5. Yeah. So what we're trying to solve, the sine signal and a line at 0.5. Do you all agree? Yeah.
Yes.
And we know we've got two answers. One is at 30 and one is at 180 take away 30, which is 150. Okay. So this is what we just did. X equals 30. The other solution, 180 take away 30. So maybe I would write it here so that you've got it as well. I'm going to change my pen color to a white. There is another solution, 180 take away 30, which is 150, because we're in that second quadrant. Okay. So
there's always two solutions with regards to solving.
yeah, so if they had asked us solve this equation between 0 and 90, then you would say, between 0 and 90, I've got only one solution. If they had asked us 0 to 180, we would get two solutions. 0 to 360, two solutions. But if they had made like 0 to 720, remember, you need to keep going with your signal here. You would get 1, 2, 3, 4. And to get the third and the fourth one, you just add 360 to your solutions there, because what happened is periodically every point here will repeat itself plus 360. So that'd be 390 and then 360 plus 150. Okay. So 4 quadrant, and that's where our solution comes from. Now, we've done for sine. Let's say we're asked to do cos x equals 0.625, again in the range 0 to 360. Graphically, what we're looking now this time, 0.625 is roughly more than 0.5, but you can see that we need to find two solutions again. Oops, let me change that color. So we're looking for two solutions, one here and one there. Yeah. So just like we did earlier on, the invert of cos x is what we call cos minus 1. So it's to get x, you need to do the opposite of cos. On your calculator is shift cos. So x is shift cos of 0.625. Remember when we were doing x squared, the inverse of squaring is to take the square root. The opposite of taking the cos is taking the cos minus 1. Okay, so to get x on its own, you need to do shift cos 0.625.
I've got 51.3178.
Okay, so then
Up.
what you could do is you can say, I'm going to put this as 51.3, but just add next to it to keep yourself right 1 decimal place. Okay, so this is us giving it to 1 decimal place. So now we know roughly that this point here is about 51.3. So now how do I find the second one? So remember what we said about cast? Where's the C? Yeah, so C was bottom right.
Yeah.
And once we've got our first angle, this time we're going to get 360 take away our angle. And you can see it physically, it's a 360 take away that 51.3. So what's 360 take away 51.3?
308.7.
308.7, yeah. 1 decimal place. Again, just make sure. Okay. So you can see how they solve it. But there'll be coming a time where you won't need the graph. The only thing you would need is to remember what cast stands for. All positive here, sine positive here, tan positive here. 180 take away alpha, 180 plus alpha. So if you know that, you can solve trig equations. Okay. So let's have a look. A couple of examples here. With the help of the graphs, using your calculator, solve the following for, what do we have there? So x between 0 and 360, which is what the graph is doing. So this time we've got sine x equals 0.259 and sine x is negative 0.5. Okay, so give it a try. Let's see what you get. Let me know how you get on. You see, so if we had more time, because I'm conscious about the time, I could have just pushed that onto your board and each of you could have started a bit of work. And if I had both the software, then I could help you by giving you a few hints how to process with this part. And that makes it a bit more interactive. So I'll speak to the college and see if they're willing to buy the license. And then that way, hopefully, it'll be less of a monologue, if you see what I mean. Because sometimes I feel like I talk too much. So for my line of working, obviously, so you would just say sine x in degree is 0.259. The opposite of sine is doing sine minus 1, that would get rid of that sign. Then that means x is sine minus 1 of 0.259. Use your calculator. So what did you get for inverse sine?
15 degrees to 1 decimal place.
Yeah, so 15 point, if you want 15.01, but if you do, you can just do 15 and just say here, if you don't want to put decimal, you can just say 2 significant figures, 2 significant factors. Yeah?
Yeah.
2 SF. That's enough to know that at 15 degree, you're at 0.259. So is there a second answer?
Yes, it's this one, the sine.
So that would give you your first mark. And the second mark, remember what we said for cast?
It says at the top, answer in 3 significant figures.
Oh, there you go. I didn't even see it. Well spotted. Answer correct to 3 significant figures. So I need to add the 0. If I don't put the 0, I don't get my third significant figures. So well spotted. But remember, like I just said, you could have someone marking you and noticing that you hadn't noticed this answer correct to 3 significant. And because you've put the 2 significant figures, you've told whoever's marking you that you've decided to put the answer to 15. So you might get, depending on who the marker is, the marker can highlight that the fact that you've given the number of significant figures and put 15. But you may get another marker thinking, oh, that person doesn't know what 3 significant figure is. That's why it's not adding the 0. But just put it, you never know who's marking you. Okay. So the other one, we said cast. Where is S positive? Here. 180 take away alpha, because I've found my first angle there. So 180 take away 15.0.
165.
So if you got a scientific calculator, don't do the 180 take away 15.0. Just do 180 minus answer. See the Casio button answer, it gives you the full number. And now this time I've got 164.989. And to 3 significant figure, you just need to put 165. Okay? That would be your 3 significant figures. So to get full marks, when you write 3 significant figures, make sure you write 15.0, and then 3 significant figures is 165. And that's you, you've got your mark here. Okay. So let's try this one. So the interesting bit is, this time I've got sine x is negative 0.5. Is that positive or negative?
Negative.
Negative. So if I put cast, can you tell me where sine is negative? Where it's not positive. So can you tell me where sine is not positive? I can ask you that question. Where it says T and where it says C. Because where is it positive? In that first quadrant, it was positive. In that second quadrant, it was positive. So when I ask you, where do you think sine is negative? You could have just said, obviously in the third and your fourth quadrant. And in terms of cast, first, second, this is my third, and this is my fourth quadrant. Okay? So I know that in my third quadrant, it's 180 plus alpha. And in my fourth quadrant is 360 minus alpha. What do I need to find?
T. The X.
Yes, so I need to find X, but if I've got alpha, where is alpha? Where is alpha usually? In which quadrant?
A.
Where it says A. So alpha is the first quadrant. So the trick when you get to solve a trig equation and you've got to find a negative number is to say, I'm going to look for the angle. So you say alpha is, so the trick first is to change X into this alpha angle that we look for, but to, instead of negative, you treat it as if it was positive. To make it easier for you, whenever you're going to have to find a negative, you need to find the corresponding angle in the positive, which is the first quadrant, and alpha is just sine minus 1 of 0.5. So what is alpha?
30.
So 30 degree.
30 degrees, yeah. I got negative.
So now I've got alpha. I know what my x's are. The first one is x equal 180 plus 30. So what's that?
210.
Yeah, 210, which makes sense. It's about here. And my last one is 360 minus alpha, 30. So you can see with the negative, you've got a bit more work to do. But the only work you need to do is find alpha as if you were in that first quadrant. So what we did is we went to find that angle there that correspond to 0.5 because of the symmetry between the two curves. It's a perfect symmetry. So if I find this angle alpha, I know that that angle alpha is here. And it's 180 plus alpha and 360 plus alpha. So basically what we went to do is find that angle. We've added it to 180 and we took it away from 360. So do you understand the trick now?
So if it's a negative,
Look for the positive corresponding one.
and then
And look at in cast, where does it correspond? Because you're looking for a negative, that means it's not positive. The only two regions where sign is negative is where it says T and where it says C.
okay.
If it was a cos, the only two regions is where it says S and where it says T. If you've got tan, which is negative, it's not in A, it's not in T, it's in this region and this quadrant as well. Okay. So now you know all the tricks about trig equation. So let's see if we've got our answers right. So 15,165, 210, I should say 15.0, 210, 330. Okay. Again, guys, make sure 3 significant figures. We're good because we've got 3 significant figures. So in these 3 examples, I've got cos x is 0.08. Is that 0.87 at the top?
0.087.
Okay. So positive in the first quadrant, quite easy to see, and in the fourth quadrant. If I find alpha, I need to do 360 take away alpha to get my answer for cos. Cos is negative. I'm going to change that to find the positive corresponding one. And then I'm going to do second and third quadrant. Okay. Tan positive, where it says all, and in the third quadrant. So if I find alpha, I just do 180 plus alpha. So you can see here. So this is going to be my alpha angle. And I'm going to add it to 180. But eventually you won't need these are just to help you to have a visualization of what we're trying to achieve. But eventually these will go and you're just going to have to say, okay, I'm one, first thing first, cast. C-A-S-T. So this needs to be in your head. Alpha, we're all positive, 360 minus alpha. The good thing is alpha and x are the same because I've got a positive thing. So x, your first answer is inverse cos of 0.087. So shift cos 0.087, which gives me 85. So we're going to use three significant figures again, 85.0. And the other one is just 360, take away that. Which is 275. Three significant figures. Okay. First mark, second mark. For the negative, we're going to look for alpha this time and treat it as if it was positive. So shift cos 0.766. 40, remember, three significant figures. Then x, what did we say? I forgot to put cast first. CA, so it's going to be here, 180 take away. This is where cos is negative, and 180 plus. So 180 take away 40 is 140. And 180 plus 40, 220.
So when you have a negative kind of figure there, you know that you would avoid A in the cast, you know, kind of.
Yeah, because it's negative. Basically, what the question you should ask, if it's not positive, it is negative.
Mm-hmm.
Cast goes from top. So yeah, remember the C start bottom right, or remember the first quadrant is where all my signal are positive. So if you write them in that order, C-A-S-T, then you should be okay.
Okay.
Unless you want to write it as A-S-T-C, but people prefer to start with a consonant and then a vowel to make it easier for them to remember. Okay. Yeah, I can see that Kirsty keeps dropping. She should be back. And for the tan, the good thing is positive. So I'm going to look for where tan is positive, 180 plus, and where it's alpha itself. So x is inverse tan of 2.75. So shift tan 2.75, and I get 70.0, yeah. And the other x with a tan is positive at 180 plus 70, which is the third quadrant.
It's 250.
250 degrees. Let's check our answers. 70.0, 250, 85. Yeah? So it's just a bit of practice. And remember, the day you're going to be having to do these during an exam, those graphs that are helping us to understand what we're doing are not going to be there. So you need to take a visual picture, a visual image of this, so that when it comes for you to do it, you've got an idea. Let's say you can't remember cast, draw your sine, draw your cos, and that would really bring you back. Okay. So in summary, we looked at cast diagram, CAST, yeah. So all positive in first quadrant. Sine is positive in second quadrant. Tan is positive in third quadrant. And cos is positive as well in all and fourth quadrant. And once you find theta angle, remember this is 180, so 180 take away, 180 plus, and this is 360, take away the angle. Okay, so it's a bit like you're trying to find, this is your first angle, theta. This is your second angle. So your second angle is just 180 here on the line, straight line, take away theta to bring you back here. In this case here, I've got 180 plus theta. So theta is always that wee angle there. And then 360, take away that angle. So we're not going to go through all these, but this is just the same as what we've just done. It's just more practice. So you can practice on them and you've got all the answers there. You can practice on these with negatives. You've got all the answers there. So now for your homework, it's lecky. So exercise 24C, question 4, page 278. Okay, so it's pretty much what we've just done. Was just practice. So if you do all the lecky and you've got no problem at all and you're happy with it, you take yourself. If you think a few of them you had not done correct, you can work on the other one that I've just put up. So the other one were from another book, which is the TJ book. So that's the one I've got in my school. But for the college, they ask us to use lecky. Okay, you've got that. So basically,
Yep.
what it is for this exercise, we're going to pick one, giving your answer to the nearest degree. So let's pick D, and I'll walk you through this one. Okay. So I've got here sine x equal negative. So I'm going to look for alpha this time in positive. But look at the question. Remember what I said? So every answer that I'm going to get, I'm going to have to add 360 to it to get to the second part. Yeah. So remember, it's a bit like we had sine x from 0 to 360. If we were to represent it, and then we've got another from 360 to 720. So if you were to draw this, negative 0.72, I've got 1, 2, 3, 4 answers. So if you only give 2 answers, you get half the mark. You need to give the other 2 as well. Okay, so the way to do this, you would go alpha is inverse sine of the positive value 0.72. So shift sine 0.72, which is 46.1, or to the nearest degree. So it's 46 degree.
Yeah.
So the question was asked to give it to the nearest degree. Now that I've got alpha, my 2 other values are x and x. I've got 2 of them. Cast tell me that sine is negative. So I'm going to use this. Sine is negative 180 plus alpha and 360 minus alpha. So 180 plus 46.
That's 226.
226.
So 226 for my first one to the nearest degree. And 360 minus my answer is 134. Yeah? Oh, sorry,
Oh, 314.
314. I typed in my calculator minus answer, but it took the last answer put in.
Yeah.
So you need to watch for that as well. It's a common one. Or you can tab back up and just equal. And now you do 360, take away answer, and it should be 314, yeah. So you can either put x in degrees 226 degree, or you can just put x equal 226. You will still get the mark. So even if you don't put the weird degree sign, you still get the mark, okay? So do you think we're done? I've got my first two. Yeah, so I need to find the other two. So the other two, because we've got a signal repeating itself every 360, the other two is just x equal 226 plus 360. That's my next one. And 314 plus 360. Okay. So 226 plus 360.
586.
586. And my last one, 314 plus 360.
674.
674. And the
Can I
quick,
just- Sorry, Adrian, I'll just double check. Obviously, I understand that since it's a negative, you have to do a bit more work in using obviously,
alpha.
you have to figure it out. It's just the 720 part. Is that just because it's two full complete cycles? Hence why you get four answers. It's like
Yeah.
double the
So you double your, yeah, if you get two, if you get if you get two of those sine waves, and you were
720.
to draw the line, you would see the line cutting those two waves in 4 points. And that's what they're asking us to solve. But
All
you,
right, okay, understandable. Yeah.
and that's why you should always look at what they ask us to do. So now that I'm done, the first thing I do is I'm looking at, have I got all my answer between 0 and 720? Yeah, 226, 314, 586. If I had here something bigger than 720, then I would ask myself, have I made a mistake somewhere? Okay, so it's a quick way for you to check. Let's say my alpha was wrong to start with, and that would have shifted all these. Then I could have spotted straight away, oh, I'm at 735. There's something not right here. So always use your answers to get you back into checking your work. So in this example here, 0 to 180. So you could quickly draw your cos signal. So 180 stops here. So it's going to be negative at only 1 point. So you only need to find that, but you need to find the first positive alpha first, and then do 180 takeaway. So again, use cast.
Yeah.
C is negative in here and there, but to be at less than 180, it's got to be here only.
Okay.
Okay.
All right. Thank you.
So that's how you would do them. So these are the same, just give you more space to do. So we're going to take a break because I've been talking quite a lot just now. I'm sure some of you guys would like to get a wee tea break or something. So to do that, I need to